All right, in this video, we are combining a few things here. We're combining expanding binomials, and we use Pascal's triangle, or what I would rather call Pascal's pyramid. To do that faster without expanding by multiplying 5 or 3 or 2 binomials together, we use a shortcut. We're combining that with compositions of functions. And if you think about a composition, like a musical composition, right? Like they write this, like a composer puts all this music together, or you think of a composition notebook, or you write a composition like an essay kind of thing. You put all this stuff together. So a composition of functions is when we put functions together. We pile them inside of each other and we make them work together into something new, right? So that's what this is, composition of functions. And this particular example, I keep doing these with you where we've been plugging in x plus h, is super important for anybody who's ever going to take a college math class, pre-calculus, calculus, any of those classes. You are going to be doing the first unit you do in there is limits, and you do the limit definition of a derivative, and you will be plugging in x plus h, or maybe you'll see something written as x plus delta, capital delta, Greek letter for D, lowercase delta, looks like that, delta x. Delta x is like a letter in itself, like its own variable. Oh, I'm kind of cut off on the screen, sorry. There we go. Delta x, and that's lowercase delta x. But you don't think of it as like x times y, right? You think of it its own letter, and delta will mean, you'll see soon in the near future, delta means the change in. So it's talking about the change in x, and we'll see why it is what it is and why we use that so much in the near future, like I said. So if f of x equals, this is a cubic polynomial, or a cubic trinomial to be more specific, x cubed minus x squared plus 3, and g of x is x plus h, which, you know, appears to be kind of linear, but we're filling in h, a constant, instead of a classic number in that spot. Find the f of g of x. So what are we combining here? We're combining expanding binomials. So we're going to do x plus h to the third with Pascal. We're going to do x plus h to the second. Honestly, you should have that memorized. You'll also have to distribute a negative. And we're going to also have to, in order to know that you even need to expand a binomial, you need to know how to plug g of x into that. So let's just go over that first. If we're finding the f of g of x, this is something that year after year every student screws up royally, just to be honest. So don't be that person. You have to know, and don't think you know when you watch your teacher do it, because every year students are like, okay, I get it, watching me do it. They don't do it by themselves, and when I ask them to do it on a test or a quiz, they produce doo-doo on their paper, and I don't want to see it. So g of x is x plus h. That's what they are, is our equal sign. These are two of the same things. Maybe this is like your formal name and your nickname. You're the same person, right? But one name may be used more in formal circumstances, and the other one maybe is more used in informal circumstances, okay? So they're one in the same, they go together. When we write things out on the left side of our equation, the way I'm going to be setting it up will be more formal, and on the right side, a little bit more informal. So this is what we need to find. F of g of x. If f of x is equal to x to the third minus x to the second plus 3, f of g of x, so on the left is where we are more formal, equals, and now on the right, we'll plug in x plus h. X plus h to the third, x plus h to the second. Now, without multiplying 3 times, x plus h, x plus h, x plus h, that's annoying, we will use Pascal's triangle or pyramid, which we go down to row 3. It's the fourth layer because this is row 0, row 1, row 2. Here's row 3. The second number in the row is the row number, and it should match the exponent that you're dealing with. So we're going to use that one technically here, and we're going to use the one above it more or less there. 1, 3, 3, 1 are what we start as our coefficients. They will be how we finish them, only because these don't have any numbers with them. F of g of x equals, or is. All right, here, I'm going to write 1. You don't really need the 1, but whatever. X to the third is how we start. H to the 0, because 3 plus what is 3? 0. Next. If it's plus, they're all plus. 3. X to the, go down by 1. 2. H goes up by 1. H plus 3 again. 1, 3, 3, 1. X goes down by 1, so just X. H goes up by 1. H squared. Plus 1. X goes down by 1, so none. 1 to none. H is to the third, and you should finish with the power you started with. Okay? Now we're here. That took care of all of that. Now I'm kind of going to white out my little guy here because it's sort of in my way, because I want to keep going straight across. So let's carry on. The next thing you need to have written down when you do an example like this one is minus. Now we really could do a couple things at once here. I had written up here, right? 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So the 1, 2, 1 is what I'm looking at. So I have invisible parentheses here, okay? 1, x to the 2, h to the nothing, 0. Plus, I shouldn't have written that. I'm not changing that yet, okay? You would leave it blank, mystery. 2, x goes down by 1, h goes up by 1. They're both to the first. Next is another 1, h to the third, because x went down by 1, not third, I'm sorry, second. And h went up by 1. And at the very end, we have a plus 3. Now, totally squeezing it. Just made it. Okay. So this negative, after you expand this was expanded. Think about what the word expand means. Don't let math just be some foreign language to you, okay? When you expand something, doesn't it get bigger, right? So this is that part expanded. What's the opposite of expanding something? I gotta watch because opposite means negative in math, so careful with that. It's factoring, and this is factored. X plus h times another x plus h, also known as x plus h squared. This negative would distribute. Normally, these would all be positive. But since I'm distributing that negative, I'm gonna get minus on minus. Everyone's gonna have minus. So really, I just saved 1,000 steps, okay? So much work was saved. Wonderful, beautiful, love it so much. Now, there's no like terms here, okay? That part corresponds to that part right there. Then the first 4 terms, that's the other thing to keep in mind. Whatever the power is on the piece that you're expanding, you should have one more than that number of terms to go with it, okay? So this goes with this, but none of the terms are like terms, nothing to combine. In your near future, or maybe if you're watching this and you're already a little bit more in the future, something that you might be working on is the limit as h approaches 0. So we don't want h to actually equal 0. We just want it to get really close to 0. So it's almost like you're plugging in 0 for h, but you can't. So you just try to get really close to it. Of f of x plus h, which is literally what we just found, minus the regular f of x. And again, you have that minus in front of the original f of x, all over h. And this is going to run your life if you take pre-calculus or calculus. You got to know how to deal with that. So I'm just going to, this one takes 2 seconds to do, not 2, but 30 seconds. So I'm just going to do that since we're here right now, and it is literally in your future in the next couple of days if you are in a pre-calc class looking at something like this right now. So what will this look like? Well, f of x plus h is already done in the problem. Where is it? It's right here. We already did it. This whole answer we just got, I know we called it f of g of x, but what did we say that g of x was equal to? G of x was equal to x plus h. So it's the same thing. So that will go right over here. We already did that part. How about f of x? F of x was in the original problem. It was this whole thing right over here. And h is just h. And that, oh, I'm kind of covering up part of the problem, my bad. And that is why h can't equal 0, okay? H is approaching, see the little arrow right there? It's getting closer and closer and closer to 0. Okay, so what do we get for the next step? We will have, I'm leaving this in front, it's like a square root. You don't just magically get rid of it. This whole part is this whole mishmash, okay? I'm going to squeeze this, but x to the third plus 3, x squared h plus 3, x h squared plus h to the third minus x squared minus 2xh, oh boy, minus, I'm going to actually white this part out because I could fit a little better, minus 2xh minus h squared plus 3. Okay, that was the whole green part. Fit it. I'm going to put it underneath. Minus f of x. So minus this guy right here. And I'm going to distribute that negative right away. Biggest thing that everyone forgets, to distribute the negative. So sad. Minus x to the third plus x to the second minus 3. All that's your numerator. All over h. Now the magic happens. This is always going to happen. Everything in your f of x, the original part right here, everything in that will cancel out with something in the first part. X to the third is negative right here. Look, negative x to the third, positive x to the third. Adios. Okay? All there, all gone. Next, positive x to the second, negative x to the second. Bye-bye. See ya. Next, I wanted to find another color pen, but nope, I'll use purple highlighter. Now here, a negative x to the third, positive x to the third. Gone. Next step, equals, keeping that limit. Oh, am I in front of it? A bit. Let's do this. How's that? The limit as, scooch it up a smidge. Okay. H approaches 0 of, and what do we have left? 3x squared h plus 3x h squared plus h to the third minus 2x h minus h squared all over h. What does everyone on top have in common? They all have h. So I'm going to pull an h out of everything in the numerator. That leaves me with 3x squared plus 3x h plus h squared minus 2x minus h all over h. Since I factored an h out, I undistributed an h from every single term. This h right here and this h right here can actually reduce only when it's attached with multiplication. You can't just cross things out that are being added or subtracted. Those are gone, okay? That's the very end of that step. Now, if you're at the point where you know how to take a limit, we always want to use direct sub. We couldn't use direct substitution here. That would give us a 0 in our denominator and make us sad. We don't want to do that. So now I'm only taking the limit of this. I can plug in 0 for h because you're allowed to get 0. You just can't get it in the denominator. So if you know how to take a limit and you understand what we're doing there, then the answer would be, for this question, the answer is 3x squared. Now this, 3xh, h is 0, 0 times anything 0, gone, plus 0 squared, gone, minus 2x minus h minus 0, gone. There it is. That would be your answer. So what we're working on first how do we fill in x plus h? How do we do a composition? Also, how do we expand binomials quickly, accurately, beautifully, and efficiently, right? Then after that, we're going to learn soon about, or you're learning it now, limits as h approaches 0 of this funky little formula. This funky little formula, this beauty right here, is beloved. This is what we call the limit definition of a derivative, and this is how you find the rate of change or slope of a curve in calculus. So if you just did this, good job, go you. You just did your very first legit calculus example. So hope this video was helpful. If you only needed up to this whole green line, well, then that's all you needed. But I hope that you were able to get something out of this second half. Thumbs up if you did, thumbs down if you hated it. Have a nice day.